3F, multiplication of integers. So we've talked about addition and subtraction of integers. Integers, remember those signed whole numbers. So when we were dealing with addition and subtraction, the signs had a little bit of a confusing effect, but I think we were able to work through that. Now, when we deal with multiplying, I think personally it gets a little bit easier than it was with addition or subtraction because it's pretty straightforward about what happens. So basically, if we take a positive number and multiply it by another positive number, we will always get a positive result. If we take a negative number and multiply it by another negative number, we will always get a positive result. If we take a positive number and multiply it by a negative number, we will always get a negative result. And if we take a negative number and multiply that by a positive number, we will always get a negative result. Now, to simplify it even more in how we think about this, we can just look at it as if we are multiplying two signed numbers. And I'm specifying two because if you're dealing with three or more, there's something else that's going to come into play. When you multiply two signed numbers, if the signs are the same, the result will be positive. If the signs are different, the result will be negative. And that's the only rule we have to remember. So if we're multiplying signed numbers, multiply the numbers and then look at the signs. If they're the same, the result's positive. If they're different, the result's negative. So let's do some of these and see what happens. Negative 5 times negative 2. We're multiplying signed numbers, so we're just going to multiply the values themselves. 5 times 2 is 10. And then we look at the signs. If the signs are the same, it's positive. If the signs are different, it's negative. We have negative 5, negative 2. Signs are the same. The result is positive, positive 10. 3 times negative 4. Again, we look at the value. 3 times 4 is 12. And then we look at the signs. We have a positive and a negative. The signs are different. Therefore, the result is going to be negative. See? That's not nearly as difficult as it was with addition and subtraction. Remember, with subtraction, we had to go through the work of turning it into an addition problem. With addition, we had to look at it, well, if the signs are different, well, which one's bigger? And then that gives us the sign. Multiplication, it's this simple. Signs are the same, positive, signs are different, negative. Now, I could do a lot more examples of it, but this is the way it works. Whether we're dealing with integers, whether we're dealing with decimals, or if we're dealing with, I hate to say it, I mean, there are young minds, young ears listening to this, but the F word, fractions, okay, it would still work the same. Luckily, we're not dealing with fractions. We haven't dealt with fractions yet. But that's it. So if I were to put a decimal in here, it doesn't have any effect on it. You multiply the two numbers, the signs are the same, positive result, signs are different, negative result. Now, where it gets a little trickier, I shouldn't really say trickier, but there's one more thing to look at. If we're multiplying more than two numbers, where people tend to get confused with the signs are the same or signs are different, is when you take something like negative 3 times negative 2 times negative 4. And they look at that and go, oh, the signs are all the same, and they want to say if the signs are the same, then it's going to be positive. And that's not the case here. Remember, I said if you're dealing with multiplying two numbers. So if we look at this and look at just the first two, negative 3 times negative 2, well, the signs are the same, therefore it's going to be positive, so we have positive 6. Now you'll notice that we have positive 6 times negative 4. So now the signs are different. 6 times 4 is 24. The signs are different, so it's going to be negative. So basically what we can do is look at this and say, well, every two values can be multiplied together and treated by if the signs are the same or the signs are different. What this does is it means that we can do a little modification to that rule of if the signs are the same or if the signs are different. What we can do is say, if the signs, or actually let me change that, if the number of negative signs is odd, the result's going to be negative. If the number of negative signs is even, the result will be positive. The number of positive values doesn't matter because that's not going to affect it. But if we look at the number of negative signs, it'll tell us whether it's odd or even. In this case, we have 3 negative signs. That's an odd number, 3. So we can say, well, it's an odd number of negative signs here, so the result is going to be negative. And then we go 3 times 2 is 6, times 4 is 24, negative 24. What this means is I can take a long list. That one's not too bad, just multiplying 3 things. I could say 2 times 5 times negative 7 times negative 1 times 6 times negative 4 times 3 times negative 1 equals. Wow, that's a pretty long expression here. So we got 2 times 5 times negative 7 times negative 1 times 6 times negative 4 times 3 times negative 1. And I want to know, is the result going to be positive or negative? Well, all I have to do is look at the negative signs and count them. So I have 1, 2, 3, 4 negative numbers. 4 is even, which means that the result is going to be positive. Now, if you remember, the commutative property of multiplication says I can move things around, right? 3 times 2 is the same as 2 times 3. So what if I were to just move these around a little bit, and I just put all the positives together, 2 times 5 times 6 times 3, and then put all the negatives together, times negative 7 times negative 1 times negative 4 times negative 1. Well, if I look at it like that, then this becomes a little more visual and obvious. If I look at my negative signs, those two, when multiplied together, the signs are the same. That makes it positive. These two put together, the signs are the same, makes it positive. And now we see that we've got positive throughout. So we can look at the number of negative signs in our multiplication. If it's odd, then you're going to have a negative result. If it's even, then you're going to have a positive result. And then going through and multiplying is the same thing, right? 2 times 5 times 6 times 3 times 7 times 1 times 4 times 1. And I could plug that, you could plug that into calculator, you can do it by hand. That gives us what? 10, 60, 180, 180 times 70, well, that's 100, what's that, 1,000, I'm going to cheat here. Just stole my the calculator from my colleague. He was probably in the middle of a calculation. I just threw it all off for him. Well, we just want to get our final result here. Oh, whatever you do, don't use times when you mean equal. 2 times 5 times 6 times 3 times 7 times 1 times 4 times 1 gives you 50, 40. There we go. And I'll return that to my colleague. So we got positive 50, 40. So So I just want to cover one more thing with this, and this is a caution. When we are dealing with multiplying signed numbers, or I should say when we start dealing with multiplying signed numbers, people get in the mindset that they have to multiply. And I see this happen at the beginning level, and I see it happen in higher level math courses. Now remember, when you're multiplying, you can say 5 times 3, or you can say 5 times 3, or 5 times 3, right? There's numerous ways that we can write multiplication, and one of those involves parentheses. Now, when we're dealing with signed numbers, we have a tendency to use parentheses when we have a negative number. So here's where the problem comes in. This 5 plus negative 10 equals. People see the parentheses and they start thinking multiplication. But that's 5 plus. This is an addition problem. So 5 plus negative 10, we're going to take the difference. The signs are different, so we're going to take the difference, which is 5, and we're going to keep the sign of the larger number, negative. So negative 5, that's an addition problem. It is not a multiplication problem. Don't go 5 times negative 10. Don't see it happen in the problem run into as often here. Where I see the problem more is things like this: 5 minus 10. Especially if they put it in parentheses, or they'll make it minus 10, right? 5 minus negative 10. Well, now people think of this minus as a negation of this, and they tend to want to say 5 times 10. And that's a problem. So this is subtraction. That's not multiplication. So we have 5 minus negative 10. So to do that, we're going to keep the first sign, change the subtraction to addition, change the second sign to be positive, which gives us 15. That's a subtraction problem. The other thing we might see is 5 times negative 10. This one is multiplication. So here we've got opposite signs, so the result's going to be negative. 5 times 10 is 50. So we have negative 50. So that's the one that really is multiplication. So there we go, the multiplication. So just be careful and be aware of this. Don't fall in the trap of thinking that every time you see parentheses, you're multiplying. If there's a sign outside the parentheses between that and another number, it's telling you to do that operation. That's 5 plus negative 10. 5 minus negative 10. 5 times negative 10. So be careful about those. But that finishes multiplication of integers.